Question 2. Apply Hooke's law to calculate the force exerted by a spring, the spring constant, or the distance by which a spring is stretched or compressed. Now, Hooke's law states that the spring force exerted by a spring is equal to the spring constant multiplied by its stretch or compression. So Fs here is the spring force measured in newtons, K is the spring constant measured in newtons per meter, and X is the stretch distance or the compression distance measured in meter. If you plot the stretch distance with the spring force, you can see that the relationship between them is proportional. When the stretch distance increases, the force exerted by the spring increases as well. If you take the slope of a line, you will get the spring constant K. So K is equal to the slope of the line in the stretch distance versus the spring force graph. You can see that from the equation, the spring constant K depends on the stiffness of the spring. So it depends on the physical characteristics of the spring. If it's thin or thick, or if it has more loops. Also, the spring constant, as we said before, is equal to the slope of the line in the FSX graph, or in the force stretch displacement graph. And it has the same unit as the slope, which is Newton per meter. So here, for example, if we have a graph that describes the stretch versus force, and the question says, what is the spring constant K from the Fx graph? We're going to take 2 points on the graph and apply the slope equation. So let's take these 2 points right here. You can see that the first point has the coordinates 0.06 and 4. So this point right here, has the coordinates 0.06 and 4. And the other point has the coordinates 0.12 and 8. We call one of the points x1, y1, and the other point x2, y2, and then apply the slopes equation. You're going to say y2 minus y1, so 8 minus 4, divided by x2 over minus x1, which is 0.12 minus 0.06. It's going to give you 67 newtons per meter. That means that this spring exerts 67 newtons of force for each meter of stretch, or for each meter of compression. Now, what does the negative sign mean in Hooke's law? The negative sign means that the stretch displacement and the force are always in opposite directions. So you can see when the stretch is down, the spring force, also called the restoring force, is upwards. But when the stretch is up, you can see that the spring force is directed downwards. So because Fs and X are always in opposite directions, we have a negative sign. This negative sign is only important in meaning. When you're calculating the spring constant or the spring force's magnitude or stretch displacement, you can just remove the negative sign and refer to the drawing for directions. The spring force is also called the restoring force. It's because the spring force is always pointing towards the equilibrium position of the mass, which is right here. That means that the restoring force is always trying to restore the object back into its equilibrium position. Let's see the questions. Question 1. What is the spring constant of a spring that stretches 12 centimeters when an object weighing 24 newtons is hung from it? So here, given is the stretch, symbolized by X, and given also is the force, the spring force Fs. And the unknown, as you can see, is the spring constant K. How much is K? Now, before you start, you must be sure of the units. K must always be measured in Newton per meter. X must be measured in meters. and the force must be measured in newtons. Any other units? For example, you can see here that the unit of stretch is centimeters, then I have to turn it to meters by dividing over 100. So x is equal to 12 centimeters, divide over 100, that gives you an 0.12 meters. And the force is 24 newtons. And the unknown is K. How much is the spring constant K? Using this equation, Fs equals to Kx, substitute, so 24 equals K is the unknown and X is 0.12 meters. Now divide both sides over 0.12 or use the calculator shift solve to solve the question. Let's get the calculator. So 24 is equal to K is the unknown, X multiplied by 0.12, and then shift calc equal, or of course we can divide both sides over 0.12 and find K. So K is equal to 200 newtons per meter. Question 2. What is the elastic potential energy of a spring with K equals to 144 newton per meter that is compressed by 16.5 centimeters? So here is the unknown is the elastic potential energy, symbolized by PE. The elastic potential energy can be found using this equation, half K multiplied by the stretch squared. Now, mentioned in the question is K and the stretch X. So you can see that the stretch is in centimeter. You have to divide over 100 to turn it to meter. So X is equal to 16.5 divided by 100. That's 0.165 meters. Now using these two, I will substitute and find the potential energy. Half K is 144 and the stretch is 0.165. Don't forget squared. Using the calculator, where is it? Using the calculator, so we're going to multiply half times 144 times 0.165, close bracket and square. A equals to 1.96 joules. So the potential energy stored in the spring is 0.96 joules. 1.96 joules of energy. Question 3. A spring has a spring constant of this much. So given is K, the spring constant. How far will a block weighing 18 newtons stretch it? So if we have a spring and attached to a block, and this block weighs 18 newtons, that means that the spring force is equal to 18 as well, because when the weight balances out, the spring force upwards would be equal to the weight of the mass. So here, the spring force is equal to the weight of the object. Always, when we attach an object to the spring force would be equal to the gravitational force applied by that object. So here I have Fg, which is equal to Fs. So how far will the block stretch it? So he wants me to find the stretch, x. How much is the stretch? How far will this mass stretch the spring? So using the same equation, Fs equals to Kx. Fs is equal to Fg equal to 18. K is 56 and X is the unknown. Divide both sides by 56 or use the shift solve on the calculator. So 18 equal to 56x and then shift calc equal, or it would be easier just to divide both sides. So it's equal to 0.32. The stretch would be 0.32 meters. A spring has a spring constant of 256 newtons per meter. So I have the spring constant given in the question. How far must it be stretched? So he wants me to find x. How far should I stretch this spring to give it an elastic potential energy of 48 joules? So given is the potential energy. So since I have a potential energy, the potential energy is equal to half kx squared. The potential energy is given to be 48 equals half. K is 256 and x is unknown. Use the calculator to find x. 48 equal to half multiplied by 256 multiplied by the stretch squared, and then shift calc equal. It equals to 0.61. So I must stretch this spring by 0.61 meters to store 48 joules of potential energy in it. Or you can rearrange the equation by first multiplying half and 256, divide both sides by the result, and then taking the square root for both sides.